In this video, we are going to introduce the SANMOTION Model No.PB Type R multi-axis driver and explain how to edit the rs485 command. This is today's outline. First, I will introduce the features of PB system and then let you know the system configuration. And after the initialization, we will talk about program works. We start at the system features. In PB system, we use closed-loop static motors. It is a static motor with sensor, so the position information could feed back to the system and avoid the motor loose step. Different from the servo system, PB will not hunting when stopped. Due to the availability of holding torque, PB system can complete standstill to the target position. High efficiency for the load heat generation is achieved by controlling the current flow to motor according to the motor load. Compared with our conventional product, the heat generation of PB motors has been reduced from 30% to 15%. High resolution is a feature of our system. It makes the motors move more smoothly. For the DC multi-axis model, the maximum resolution is 12,800 points for each rotation, and the maximum of the DC model is 10,000. AC model can up to 60,000 points for each rotation. We have two types of power source and three kinds of control mode. Point command control is to start up the preset point or program with the IO signal. Network control is to communicate with rs485 protocol. And we can also control our driver with pulse generator. In this case, we control Type R multi-axis driver with the network control mode. SANMOTION provides a wide range of motors such as standard, low backlash, harmonic gear, electromagnetic brake, and the spur gear model. System configuration. Controller and driver will communicate with rs485 protocol. The driver will control 4 motors by the current flow, and the encoder will feed back the position information to the driver. Now we start to introduce the initialization. 3 functions must be set by the digital switch. Switch 1 and switch 2 will decide the baud rate. The SX effective or not will decided by switch 3 to, and we use switch 7 to 10 to set the terminator resistance. And in this case, we turn all the switches on. Our driver has protected function. LED 1 let us know if our driver turned on or not. And the alarm status can be monitored by watching flash interval of LED 2. And the meaning of each alarm has shown as the table. Now talk about wiring. Channel 1 is I/O port. Channel 2 and Channel 3 are used to communicate with the network. Channel 4 to 7 are used to connect with the encoder line. Channel 10 is for the power cable. Channel 11 to 14 are used to connect with the motor cable. And the rotary switch can set 16 address. Now we start to introduce data format. No matter we send the command or receive the ACK, data format is fixed. We divide the data into 5 parts. Package length defines the number of the byte we use. We can set 16 kind of address, and the effect axis we should set by bit 4 to 7. Specific the command code defined in the instruction manual. Status byte contains information about the communication and driver status. The number of data bytes depends on the command. Checksum is calculated by adding all bytes except the checksum and taking the lowest byte. This is an example of command editing. We use this command to read the model's absolute position. First, we calculate the packet length. We use 4 bytes in this command. Second, we set the driver's address to 0, and today we read the data of XX1 and 3. Third, the command code is 84. Last, we calculate the checksum. It is D8. Program edit. When we need to store the program data into the driver's memory, we have to use a program store command. You can see data divided into 4 parts, including program number, program line, the command code we use, and its data. And the detail of data should depend on the command we used. This slide shows the motion flow of the demo video, where the motor XX1 and XX3 drive in the speed of 750 revolutions per minute and move 4,000 points. Both accelerate and decelerate are 7.5 revolutions per minute each millisecond, and we wait for 500 milliseconds after the motor stops. A loop counter will be set to repeat both actions for 10 times. After editing, we can make the command list like this. Program debugging. We can debug the program by program read command. In this command, we can know the data we stored in which line of the which program. And this is an example. We send a command to ask what's the data we stored in line 2 of the program 0. And the driver responds, in this line, first SX and third SX are effective. The command code we use is 62. The data we store are 01, 02, and 00. Commonly used command. This is the definition of the command to let our program start. And this is the command of program stopped. And now we are going to watch a video of the motor's movement. The movement of the motors depends on the example we explained at the program store. This is the end of the introduction. If you have any question, please send email to us. Thank you.